So today we're going to look at permutations, and I suppose a good example of how permutations are used, if we look at the lock, like so, the different combinations, we need to know the different outcomes that we could have. And then, for example, if we say that the first number needs to be 7, well then what are the total number of outcomes if the first number has to be 7? So that's what we use permutations for. Okay, so you're going to see this definition in your textbook. It's a good definition to take down, but I'm going to just explain it to you very simply. So if we take the word lock, how many different ways can we arrange those letters? So we know that for the first letter, we have 4 options. For the second letter, we have only 3 options because we've already put one in for the first. For the third letter, we have 2 options. And for the fourth letter, we will have 1 option. So 4 by 3 by 2 by 1. And if I put that into my calculator, 4 multiplied by 3 multiplied by 2 multiplied by 1, that will give me 24 different ways. However, with permutations, we have a new way of doing this, and what we can do is we can put in 4 factorials. So I'm just going to show you really quickly where this button is on your calculator, and it will give you the exact same thing. Okay, so for 4 factorial, I have the 2 types of calculator here. Just message me and let me know if there's another calculator that you have that you are really not sure, because I think these are the 2 that everybody has. So what you'll see is that you will have just here, so just here above that button, x to the power of -1, you'll have x factorial. So what you'll need to do is you'll need to put in 4 and then press shift and press this button, and then when you press equals you will get 4 factorial. Okay, on the sharp calculator then you're going to see the factorial button is just here above the 4 button. So what you'll need to do is you'll press 4, press second F, and then press that 4 button again to get n factorial, and that will give you 24 when you do that in your calculator. Okay, so let's take the word spring. How many ways can the word spring be arranged if there are no restrictions? Well, there's 6 letters in spring. So what we can do is we can just use our factorial, 6 factorial, and that will give me 720. The first letter must be G. So if the first letter must be G, then we know there's only 1 option for the first letter. But for the other 5 letters, any combination will do. So that's going to be 5 factorial. 1 multiplied by 5 factorial, which will give me 120. The first letter must not be G. Well, that's really straightforward. All we're going to do is take the total number of outcomes minus the outcomes that have G as the first letter, and that's going to give me 600. And the first and last letters must be either S or N. So this one might be a little bit more difficult, but we'll get through it. So the first and last letters must be either S or N. Okay, so think about the first letter. So for the first letter, it's either going to be S or N. So we have 2 options there. I always say the best thing to do is fill in the restrictions first. So let's look at the last letter, which will be the 6th letter. So if we have put in S into the first one, then we only have 1 option for the last one, and vice versa. If we put N into the first one, we obviously only have S for the last one. And then for the middle, so that's the middle 4, so all the guys in here, there are going to be 4 options, so that's 4 factorial, and I'm going to multiply them. And when I do so, I get 2 multiplied by 4 factorial multiplied by 1, and that will give me 48 different combinations. Let's look at our lock that was on the first page. How many different combinations are possible if all numbers must be different? So we won't be able to use factorial here because we only have 3 possible lock parts. So what we have here is, we know that the options are 0 to 9. Okay, I'm not going to write out all the numbers. So that's 10 different numbers. Okay, so 10 options for each one. However, what we know is that for the first one, we'll have 10. For the second one, we'll have 9. So for the first, we'll have 10 possible options. For the second one, so that's this guy here, we're going to have 9. And then for the third one, we are going to have 8. So the different combinations there, 10 by 9 by 8, gives me 720 combinations. Let's look at a little bit of a trickier question. How many arrangements are there if the first number must be a multiple of 2? So first of all, let's think between 0 and 9, we have 2 is a multiple of 2, because 2 by 1 is 2. 2, 4, 6, and 8, there are multiples of 2. So if the first number must be a multiple of 2, and I haven't specified anything else here, so they haven't told us that all the other numbers must be different. So what we know then is that for the first number, so we fill in the restrictions first. For the first number, we have a possibility of 4 options. For the second number, because they didn't say anything about can they be the same number or anything like that, we know then that there's an option of 10. And for the third number, there is an option of 10 as well. Okay, and then we can pop that into our calculator. So 4 by 10 by 10, we'll get 400 different outcomes. And just one more example here. If the first and last must be a multiple of 2, but they cannot be the same number. So the first, again, fill in the restrictions. First, third, second. I find it handy to kind of write them out like this. So I know if the first number, I have an option of 4, because I have either 2, 4, 6 or 8. Now, if for example 2 comes out in the first number, I can't have 2 in the last number. So I know I've only 3 options there. And again, it did not say, it only said that the first and the last number cannot be the same. So the second one, we actually have an option of 10 different numbers there. So 4 multiplied by 10 multiplied by 3, that gives me 120 different combinations.